Hi, and welcome to my presentation on why to study. So I'm Caitlin Jackson and we'll just get started. So a little bit about me first. This is me and I kind of put myself in like a sciencey me and this is me outside of science, which is normally with my dogs. I do other things with my dogs as well. So kind of, life doesn't always revolve around science. I love to build Lego, I'll admit it. I draw, I play volleyball, I'll read, and I don't read science all the time either. I read like girly stuff, if that's what you'd say. And I love to cook as well. So, it's not always about science. And also, a bit of a fun fact about me, my family live on a farm. So when I'm also not in science and I go visit home, these are the animals that I'm surrounded by. And these are actually our animals too. Cute animal pictures too. So where did I start? So I went to this school, Royal Grammar. I had 10 GCSEs and 4 A levels in science and maths. And then from there, kind of in school, you always talk like, okay, right, you're going to go to uni. What are you going to do at uni? And it's, for me, my personal choice is between engineering and medicine. But when I thought about engineering, I thought about mechanical engineering. And I went to Jaguar Land Rover and I saw all these people in basically that image where they're all in high vis in jumpsuits in this massive factory, and it put me off massively. I was like, that's not what I want to do. Then there was the medicine side, and I said, oh yeah, I like medicine, but something also just didn't sit right there. But I kept going and I went to these kind of events and, where explore your future sort of events, what's on offer. And I found out about bioengineering. And this is the University of Sheffield's definition for bioengineering. And I think the first part was really critical for me. So bioengineering is where engineering meets medicine. And I was like, oh my gosh, this is exactly what I need. So that's kind of where I got my inspiration. So definitely kind of a how to start. Go to these events that your school's put on or outside of school puts on, where they can kind of say, this is the range of things you can do, because there's so many subjects you can do that you actually don't realize are there. So definitely go out and explore your options. So like I just said, undergraduate degrees, there's hundreds of courses available. And I think the first thing you need to look at once you've found courses is the grade requirements. And these are going to change from uni to uni. So, look everywhere. For mine, it was, for a bachelor's, it was AAB. And if you wanted to do a master's within it, it was 3As. So yeah, everything's quite flexible. So have a look around different unis. And I also think when you're looking at unis and, why should I study here? Why should I go there and do this? Have a look at what the unis have to offer you. Because, you're, in the end of it, it's you kind of paying to go to them, if that makes sense. So, there's academic facilities, what have they got? Have they got like labs that are dedicated to your subject, or your kind of like engineering for me? What contact hours have you got? Have you got tutorials? Do you have lab time if you're a sciencey person? Do you have like trips, that are involved? Year out to your industries, year abroad, all that sort of thing. If that's what you want, go and have a look at that, if that university offers that for you. Also location, do you want to be in a big city, a small city, like rural? Do you want to be on a campus, or you're not bothered about campus? Or do you want to be close to home? Or actually, do you know what, I don't mind, how long it takes me to get back home. I'm not bothered about that. And then also kind of life revolves outside of study as well. We always have to remember this. Study is only one part of your life. And so clubs and societies, what is that? There's so many clubs and societies out there at every university. So really, see if it's the one you want is available. It most likely will be, and go for it. But I think actually one of the most important kind of choices is, why should I go and study at a place, is you need to go and visit and just have a little feel. I rocked up to quite a few universities, and the one that I got the best feel for was Sheffield. And I kind of got there, I left, and I was like, do you know what? I really like that. I like the department. I like their talks. I like the uni. I just liked everything about it. So yeah, definitely go, see how it feels. Does it feel right? Does it feel wrong? And it really gives you a help. So I just want to take a bit of a side step, because some people are like, I can't afford university. How do I afford it? How does this work? So I think it's important to know that everyone can afford it, and it is for everyone. So everyone is allocated the same student loan fees. So this is the £9,250 that covers your academic money, if that makes sense. And then you also get a maintenance loan, which is based on your family income for your living costs and like so your rent and all that sort of stuff. And so when you repay your loan, it is solely based on your income. So it doesn't matter if you finish with a massive student debt or, you know, a really small student debt. I say student debt. You will only pay back depending on what you earn in your job. And on top of this, you only repay 9% of everything you earn above, well, currently it's above £27,295. So if you earn less than that, you don't repay a single penny. And it's also 9% above that. So for example, if you earn 28,000 in a year, you actually only repay £63.45 that year. So when you kind of start to crunch numbers like this, you realise actually, okay, it's not that much. And after 30 years, it's gone. And it doesn't work like a normal loan. So, you know, if you're sat out there thinking way into the future and thinking, oh, well, what if, you know, like credit, it doesn't affect credit or anything like that. And so a lot of people say, don't look at it as a loan, look at it as a student contribution is what they say. And you only contribute if you're able to, if you can afford it, if your salary at the time can afford to contribute back. So yeah, please, if you've got worries about kind of affording university, I hope this settles your mind a bit, and don't worry about it. It's fine. Everyone can go, everyone can afford to go. And there's lots of kind of options out there if you need extra money for grants and stuff that is, you know, you can look into. So let's go back to kind of why I kind of show you my motivation and where I went from. So why did I decide to go in Sheffield? So for me, I liked that it was a small city and it kind of had like the peaks around it. They also had this brand new building when I came called the Diamond, which is in the picture there, that funky building. And that was a building that was made just for engineering. So there's specialized labs all for undergraduate engineering too. So that was really critical as a nice space for undergraduates to have labs and stuff. But the Students' Union was number 1 in the country, and I think it might still be. So yeah, there was loads of activity going on there. There was kind of like loads of things to do, nights out and all that sort of stuff. And also like the city is because the city is quite small, you know, you can be at uni and then you can be in the city centre in like a 10-minute walk, which I quite like. So then I thought, I'd tell you, why did I want to do a PhD? Because some people think, oh my gosh, you're crazy. You've done 4 years at uni and you want to do another 4. But as I went through my PhD, I realised that, you know, I actually really like this lab bit. I really like the research and hands-on and doing stuff and kind of finding out why. And you have to kind of put up with things going wrong. But that is all part of a PhD, unfortunately. So those top images are me and my lab work. And then you might ask, okay, so why biomaterials? What is biomaterials? So biomaterials is kind of any material that kind of interacts with your body, either like just on the surface or inside the body. And actually, when you think about it, it affects so many walks of life. So even like simple things like contact lenses, that's a biomaterial. Hearing aids, heart valves, common. Joint replacements, hip and knees, very common, like pins and plates that you have when you break a bone, biomaterials. Stents that people have, skin grafts, all kind of biomaterials and related to biomaterials. And so for me, that motivated me that it's all these things that you see in everyday life that actually motivates me to kind of improve them to help other people, that's the medicine part for me, being able to help people using engineering. So what is my project that I'm currently doing? So this is the title, I'll break it down. So the title is A Lab-Based Produce Vascularized Tissue for In Vitro Lab-on-a-Chip Models of Healthy and Diseased Tissues. Now I understand when you first read that, it does make no sense. So I'm going to break it down bit by bit. So first of all, lab-based produced. This just means it's made in the lab. Literally that. Vascularized tissue. So this means that it has blood vessels or blood vessel mimics going through it. And it's a tissue like your human tissue, or it's actually a fake one. So it needs to be a material that is able to have blood vessels going through it, or blood vessel structures going through it. For in vitro lab on a chip models. So in vitro just means in the lab, or out of the body. So in vivo means it goes in your body, in vitro means it stays out of your body. And then lab on a chip, it means, I'll explain what lab on a chip is in a minute. So, and healthy and diseased tissues, that one's pretty straightforward. That I want to model either healthy kind of tissues or cells, or I want to model like diseased tissue or cells. And for me, I'm really interested in looking at cancer, and kind of seeing how cancer cells work. So lab on a chip models. When I hear that word, I literally think of this, which is a little lab shrunken down on a little chip. Unfortunately, it's not quite like that. We're not so sophisticated yet. So actually, lab on a chip models come in a range of different designs, and they're all different, but they all have this one thing in common, that they're all microfluidics. So they all have very small channels where fluid can flow, but micro, so very small. Okay. So my project looks at cancer metastasis, which is the spreading of cancer. So this is where it goes from a primary site, so from like your lungs, and it travels through your body via blood vessels or lymph vessels to a secondary site, such as your bone, which is shown in this kind of a little video here. So actually, when you then start to look into it even more, you realize that there's a whole bunch of steps that the cancer cells have to go through to move from one area to another area. And there's 2 points called intravasation and extravasation, but really in simple English, this is the entry and the exit from blood vessels. And this is what I really want to look at, because like I said before, I've got this vascularized tissue. So I've got this tissue that's got vessels in that I can look at the cells moving in and out. So yeah, there's the 2 main parts right there in the diagram. So how am I going to do this? Because it all sounds very complicated. So I use porous emulsions, which I cure using UV light. So I'll break this down again. So what is an emulsion? Emulsion is made up of 2 liquids that don't mix, and we're able to mix them using an emulsifier. So an emulsifier in the kind of everyday things that you will see, egg and mustard. And actually, an emulsion that everyone will know is mayo. So normally mayo wouldn't mix, but the egg and mayo lets the 2 liquids mix and form mayonnaise. So if you're struggling to kind of think, okay, what does this look like? I kind of describe my work as I make these sponges. And look, I mean, this is a sponge, but they don't look too far off. And so when I look at these sponges really close at the surface using electron microscopy, which is just a microscopy technique, they look like this. So I have these little pores, which is like the kind of ball structures you see, and they have little windows, which are the little holes in the balls, which allows everything to interconnect so that, you know, fluid can flow through and stuff like that. Very similar to when you think about a sponge, how water can go right through a sponge, very similar. And then I can use 3D printing. So I use this cool little funky machine called a BioBot, and it prints in whatever shape that I tell it to. And it has a little light built in so that when it prints, it can also cure the material. So it hardens the material and it cross-links, what it's called. And I get my final material. And then I can use this scaffold in cell work, and I can see, okay, how do cells like this? Do they work on it? Do they not work on it? And I can build from there. So I can build models using this BioBot. So I can make designs into a computer and then put it into the BioBot, print it, and then I can grow cells on it, see how the cells react, how they like it. Do they form blood vessels? You know, will they move in and out of these vessels that I make, and so forth. Okay, so that's enough about my project. I'll leave it there. But I think finally, why study? Study because you want to. And that doesn't mean, okay, I don't want to study today, so I'm not going to do anything. That means, you want to go, whatever you want to do in life, you have this end goal, or hopefully you have an end goal of what you want to do. And you need to do whatever you need to do to get there. So study because you're motivated to do it. Don't choose to do something later in life that you don't want to do. You need that motivation to get you through it. So pick something that really motivates you, really gets you going, no matter what it is. If it's engineering like me, or if it's, arts or English or anything, whatever motivates you, choose that and run with it because you want to study that. You're going to be interested, and that's how you're going to get the most out of your study experience and also out of university.